So hello everyone. So today we are going to discuss on decoders. So decoders is reverse of encoders that we have seen in the last tutorial. So encoder, if there we have 2 to the power of n inputs and n outputs, whereas the decoder is reverse. It has n inputs and 2 to the power of n outputs. So let me put in a proper statement here that decoders have n inputs and 2 to the power of n, I'll write later, 2 to the power of n outputs. So 2 to the power of n, we can write 2 to the power of n outputs. This is how we can write it. So this is the basic definition of decoder. So let's see the block diagram of decoder. How does it look like? So now select. So I'll take 3:8 decoder. So in 3:8 decoder, we'll be having the 3 inputs, that is A, B and C, and we'll be having the 8 outputs here. So let me call 2, 3, 4, 5, 6, 7 and 8. So here I have the input A, B and C, and these are my inputs, that is D naught. So here I can call D naught, D1, D2, D3, D4, D5, D6, D7. So these are the inputs. So this is 3. So this is 3:8 decoder. We call it as DEC in short. So how does it work? So let's see the working of this decoder. Now, for example, if it will generate a 0, 0, 0, if the combinations of binary inputs here are 0, 0, 0, then it means the first output will be 1 and all other outputs will be 0. And all other outputs will be 0. So likewise, if this is 0, 0, say 1, then what happens is that the next output will be 1. Now for example, here we can write all other inputs are 0, but this D1 output is 1. So likewise, as the binary value changes, so respective outputs will become 1. So this plays a very important role in few of the digital circuits where you have the binary data and you want to convert that to individual outputs. For example, 0, 0, 0 means you have to connect that to a line 0 and you have to make that particular line on. So then we'll make the inputs as 0, 0. Next, the second line you want to make it on, so then we'll make the binary value as 0, 0, 1. You can think of an applications where, for example, you have some shift registers. So you have 3-bit shift registers, so where or it might be any digital circuit where you are generating the binary values, so 3-bit binary values, and you want to make the LEDs on based on these binary values. So in such kind of applications, so these decoders are used. So let me write the truth table, then I will come to the application part. So if I write the truth table here, so then I have my inputs as A, B and C, and then my outputs are D0, D1, D2, then I have my input as D3, then D4, D5, D6, D7, yeah, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, yes, it's fine. Now when the inputs are 0, 0, 0, so then what happens is first D0 will be 1 and all other outputs are 0, like this. Next 0, 0, 1, so then what happens, we have this D1 output is 1 and all other outputs are 0. So like this, if you can write here, so then we have 0, 1, 0, then this is 0, 0, 1, 0. So this is 0, 0, 0, 0, 0. So then when we make this as 0, 1, 1, then we have this 0, 0, 0, 1, 0, 0, 0, 0. So like this we can continue. I'll leave it to you to fill this. So I'll straight away write the final value. So we have all zeros except D7. So D7 output we'll get here as 1 for all the possible inputs. Now we will come back to our application side of this decoder. So if you want to talk about the applications, now you have some circuit which generates the binary values. Uh, you can think of say counter. Counter is a circuit which will generate a timer, or a counter which will generate the binary values. So we will see the counter circuits later. Using these flip-flops we can design the counters. So that counter is generating these binary values, 3-bit binary values, and based on that binary value, so you want to make the LEDs on. For example, you're making these serial sets and you want to make that on. So how to make that? So let me take one application here, an example. So I'll just show for a couple of inputs here. So remaining you can just think of it. So for example, it is say this line is connected with an LED here. So this LED and this point is grounded here. So likewise there is another LED connected here. So likewise there are 8 LEDs are connected and then to the ground. Assume like that, like this. All the outputs are connected to LEDs. So now these are connected to common cathode configuration. Common cathode means all the cathode of these LEDs are connected to ground. So it means these LEDs will be turned on only if we give the logic 1 or the positive voltage. So now for the inputs, now what happened here is that now when all the inputs are 0, 0, 0, then which LED will be on? Then this first LED will be on and all other LEDs will be off. Next, if the input will change to, now if you make this 001, then the second LED is on and all other LEDs are off. So like this, one by one all the LEDs will be turned on. So you can think of as a serial set where one by one all the LEDs will go like in a serial wise. One will on, then next will on, next will on. So like this you can think of any kind of such applications which you can design, like a moving serial set with one LED on. So this is one of the application. You can think of as many applications you can, whatever you want to do it, right? So this is one of the application. Hope you understood and enjoyed it. So if you go with another input, say if you make this as say 0, 1, 0, so what happens? The next LED that is at this point will make it on and all other LEDs will be off. This is a very good example. You can try at your home if you have a decoder, or you can try at a native. Just need a breadboard, a couple of LEDs and decoder. And for binary you can just connect a plus 5 volts right away here, whichever line you wanted. So then you can make the respective line as 1 or 0. So now let us look into the logic circuit of this decoder. So logic circuit, again the same thing. So for D0 its value is this, then for D1 its equation is this. Then we are going to write all these 8 terms here, and then we are going to add all the 8 terms. So that is the expression for this. So basically now if you see, not adding, uh, so let me clear this section. Now this is not required. I just move this part somewhere here down. Yes. So now if you look into this circuit, so now to obtain the D0 output, so it means I have to connect 0 with the complement of A. So for that what I will do is that I'll take the 3 lines of A, B and C, and I'll take the complement of all these. So what I will do is that I'll take the complement by connecting this to a NOT gate here. This is my A, and now I'll connect this to my B here. So then okay, then this is my A, B and C inputs. Now to get the D0 output, what I need to do is that I'll take one line from here and one from B bar and one from C bar. I'll take it and I'll connect to one AND gate, and then that will give me an output of D naught. So like this, it is, you can just think of a multiplexer. Even in the multiplexer we have similar kind of circuit. Only thing is that where ABC and the outputs we have written as I0, I1, I2, it means we have additional input, that is I0, I1, I2, like that. So here we don't have that additional input because we are not going to transfer anything from input to output. We are just making the outputs 1 and 0 based on the combination of inputs. So now if I want to write for D1, so what is the equation? That is A bar into B bar into C. So A bar I'll take from here. So this is my A bar. So then this is my B bar, and here I'm going to take from C. So connect this to the AND gate here, and then this is my output D1. So likewise you can connect for all the use the AND gates and connect the respective A, B and C in the form which is required to get the respective outputs. So I have just written for 2, then I'll leave it to you to write for others. So I'll write the last one. So that is, the last one is A, B and C. If you look into this, so this is A, B, and I'll extend this line here. So this is C. Then I'll connect this to my AND gate. So this is my D7. So this is how the outputs of our decoder. This is the logic circuit of the decoder. So hope you have understood this and enjoyed this session. So next we're going to talk about the sequential circuits.